Okay, so gives to energy we have seen it is net energy available in any system, right? Definition देखा था हमने when we derived equations for A, which is Helmholtz free energy, and G, which is Gibbs free energy, and G is at constant temperature and pressure, and most of the chemical systems are operated at constant pressure and temperature. So it is net energy available in a system. And when we say delta G means when we move from state 1 to state 2, what is the net energy available when system moves from state 1 to state 2? Suppose you take a system and change the temperature from say 225 degrees to 300 degrees or 300 to 400. So what is the net energy available? Okay, so that is delta G. Right? Chemical potential में define किया था partial molar Gibbs free energy. And what is partial molar Gibbs free energy? It is nothing but contribution of a component to the Gibbs free energy of a solution, right? If you take a solution, what is the contribution of individual component like methanol, ethanol, जो भी components हैं, उनका contribution क्या है towards the Gibbs free energy? That's how we define the partial molar property. ठीक है, इतना समझ में आया था? Is this much clear?
Yes, sir.
Okay. Now I want to correlate this with something else. Potential energy क्या होता है? What is potential energy? पढ़ा है कि नहीं? Potential energy, kinetic energy. Who can tell me what is potential energy?
Sir, energy of a body in its stationary form.
What does it depend on?
Height.
Height. So it depends on height. अगर कोई बॉडी है, कोई स्टोन लिया हमने, 4th फ्लोर पर रखा हमने, राइट, तो उसका पोटेंशियल ज़्यादा रहेगा, कम रहेगा. किसी को 7th फ्लोर पे रखा, राइट, 70 फीट पर, तो उसका पोटेंशियल डिफरेंट रहेगा. सो इट इज बेसिकली हाउ मच इज द what we call as energy possessed by body due to its elevation or height, right? mgh, that is the potential energy. So potential का मतलब क्या होता है? This is potential energy. What does potential mean? When I say this boy has a huge potential, what does it mean? Or Devendra has huge potential, what does it mean?
Ability.
क्षमता sir. Ability.
Right? So what it means is capacity to develop into something in the future, right? यानी एक अच्छा इंजीनियर बन सकता है, सक्सेसफुल इंजीनियर बन सकता है, सब हो सकता है. आई एम जस्ट टेकिंग एन एग्जांपल, राइट? सो पोटेंशियल मींस व्हेन से पर्सन हैज अ पोटेंशियल, दैट मींस ही कैन डेवलप समथिंग, ही हैज अ कैपेसिटी टू डू समथिंग, बराबर? सो व्हेन वी टेक केमिकल एंड पोटेंशियल टुगेदर, राइट, केमिकल पोटेंशियल है, राइट, सो इट बेसिकली और केमिकल ससिंग और केमिकल ट्रांसफॉर्मेशन potential available. बता रहा हूँ अभी आपको. So for chemical transformation or for जैसे जो हम सीखने वाले हैं CET 2 में, they are all chemical transformation. Whether we talk about phase equilibrium or whether we talk about reaction, they are specifically related to changes in chemistry or chemical compositions, right? So what is the potential for chemical transformation? And that is what we call as chemical potential. ठीक है, एनालॉजी समझ में आया?
Yes, sir.
Okay. So chemical potential is chemical capacity or energy available. So when we say about energy, basically we are saying इतना energy available है, ये करने के बाद हमारे को इतना energy मिलेगा. That is why that phase transformation takes place. That's why vapor liquid equilibrium happens. That's why reaction happens. Energy नहीं रहेगा तो कुछ नहीं होने वाला है, राइट? ठीक है, समझ में आया केमिकल पोटेंशियल का मीन, लिटरल मीनिंग या फिजिकल सिग्निफिकेंस? Okay, so now we have seen that chemical potential of ideal gas is a function of pressure, right? देखा था हमने, G is equal to dG is equal to RT dln P, pressure, right? So pressure पे डिपेंड करता है आइडियल गैस का केमिकल पोटेंशियल, दैट वी हैव डिराइव्ड फ्रॉम आइडियल गैस, बराबर? But for real gas, we cannot use this pressure, and that's why we define a effective pressure and say chemical potential of real gas is a function of fugacity, which is nothing but effective pressure for real gas. And why fugacity? Because it accounts for non-idealities. रियल गैस में नॉन आइडियलिटीज रहता है, इंट्रैक्शंस रहता है बिटवीन मॉलिक्यूल्स रहता है. सो वो इंट्रैक्शंस को अकाउंट करने के लिए वी इंट्रोड्यूस दिस फ्यूगासिटी इंस्टेड ऑफ प्रेशर फॉर रियल गैसेस. समझ में आया इंपॉर्टेंस ऑफ फ्यूगासिटी, व्हाई वी आर यूजिंग फ्यूगासिटी, व्हाई वी आर डिफाइनिंग फ्यूगासिटी लाइक दैट. समझा कि नहीं समझा? एनी डाउट्स? No response. Yes, no, don't know, don't understand.
सर फुगासिटी की वो डेफिनेशन नहीं समझी.
क्या नहीं समझा?
डेफिनेशन में जो बताया है ना वो नहीं समझ पा रहा.
क्या 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 नहीं समझ में आ रहा? बताओ ना, डेफिनेशन में क्या था?
मतलब उन्होंने जो एनालॉगी यूज किए है ना, मतलब कि रियल गैस और इफेक्टिव प्रेशर का, वो नहीं समझ रहा.
इसमें समझना क्या है? वी आर जस्ट सेइंग कि प्रेशर इज नॉट एप्लीकेबल फॉर रियल गैसेस बिकॉज इंटरेक्शंस बहुत रहता है. आइडियल गैस में क्या था? इंटरेक्शंस नहीं रहता मॉलिक्यूल्स का, इसीलिए हम प्रेशर यूज कर सकते हैं टू डिफाइन द मैकेनिकल प्रॉपर्टीज. फॉर रियल गैसेस वी कैन नॉट यूज इट, दैट्स व्हाई वी आर डिफाइनिंग फ्यूगासिटी. सिंपल टर्म सिमिलर टू प्रेशर, यूनिट्स भी वही रहेगा, प्रेशर का यूनिट्स रहेगा उसका सेम. इट्स बेसिकली इज गोइंग टू फंक्शन एज अ प्रेशर substitute for real gases. So if I take PV equal to nRT, I cannot use that equation for real gases. So if I write instead of P, fugacity into V by V equal to nRT, maybe I can use it. So because I am accounting for pressure for real gases now. समझा क्या?
ओके सर, समझा.
और किसी कोई डाउट है? Okay. So let us go back to temperature dependency of fugacity. क्या था, derive किया था हमने. This was the effect of temperature on fugacity. Derivation किया था कल हमने. And we know that equation for G is equal to G0 plus RT ln F by F0. ये derive किया था हमने कल, right? So if I take G0 on the other side, what I'll get is, and divide by T ln F by F0. This term is equal to G by T minus G0 by T. Now I differentiate with respect to temperature at constant pressure. So what I'll get is R double ln F by double T at constant pressure. And this ln F by F0 is nothing but ln F minus ln F0. So minus double ln F0 by double T at constant pressure is equal to double G by T at constant pressure minus double G0 by T at double T at constant pressure. So we are taking a differential of this partial derivative. Now we use Gibbs-Helmholtz equation, so we derive that. dg is equal to vdp minus sdt था, ये हमने derive किया था, fundamental property relation. So at constant pressure, what we'll get is double G by double T at constant pressure is equal to, this becomes 0 dp, so minus s. Now if we take the derivative of numerator upon denominator, it is equal to denominator into derivative of numerator minus numerator derivative into derivative of denominator by denominator square. So if I take this term double G by T at constant pressure and use this formula, so what I'll get is, it is denominator is T into derivative of numerator double G by double T at constant pressure minus numerator is G into derivative of denominator, which is double T by double T, that is 1 divided by T square. ठीक है. So if you substitute for this double G by double T at constant pressure, that is minus S, what you'll get is equation 14 minus ST minus G by T square. And we know that G is equal to H minus TS. And so if you take H here and G here, what you get is minus H is equal to minus G minus TS. Right? This is nothing but minus G minus TS. Numerator यहाँ पर. So this becomes minus H by T square. So this is our Gibbs-Helmholtz equation. Double G by double T at constant pressure is equal to minus H by T square. ठीक है. Now we take the old equation 11 जो डिराइव किया था हमने यहाँ पर, ये equation and substitute. Substitute किया यहाँ पर, ये equation substitute किया Gibbs-Helmholtz equation. So what you'll get is left hand side remains same, right hand side is minus H by T square minus of minus H0, G0 है तो H0 रहेगा by T square. But we know that for ideal gas, F0 is equal to P0, right? Low pressure पे viscosity is equal to pressure. So equation 11 will become this equation. This is 0. Why is this term 0? Because at low pressure, F0 is equal to P0. So it is double ln P0 by double T. And we can show that if you plot PV versus pressure, and you get straight lines which all merge or converge to a point here which is constant. So that means at low pressure value, PV is equal to constant. That means it is not a function of temperature. It doesn't matter, it doesn't change. Okay? This is a graph we must study in CET 1. If you plot P versus P, all lines will merge and they converge to one point at very low pressure. So this shows that at very low pressure, this PV is equal to constant, so it is not a function of temperature. Right? So we can take this derivative as 0 because it's not a function of temperature, and this we get only this term. So R double ln F by double T at constant pressure is equal to H0, which is positive, minus H divided by T square. We take R here, double ln F at constant pressure is equal to H0 minus H by RT square. ठीक है, इतना समझा?
Yes,
That is
sir.
the effect of temperature on viscosity. Where H is molar enthalpy at any given pressure, and H0 is at very low pressure. This is similar to what we had seen for chemical potential. वहाँ पे ऐसे इक्वेशन आया था. ठीक है, any doubts, questions on this temperature dependence?
Sir,
Yeah.
सर वो मैथमेटिकली समझा लेकिन वो नहीं समझा सर ग्राफिकली कि कैसे आएगा क्या आएगा.
ग्राफिकली क्या नहीं समझा?
कि how is the temperature depends on the effect of temperature on figures.
ये ऑब्जर्व्ड है, ये डेटा से है, एक्सपेरिमेंटल डेटा है ये पूरा. If you plot P versus P, ये converges to one point at very low pressures. प्रेशर जैसे बढ़ता है, deviation change होता है, but at low pressure it becomes almost constant. It is experimental data, observations. ठीक है?
Yes sir.
Okay, so effect of pressure लेने का है, effect of temperature हो गया, effect of pressure
सर वो
dg, yeah,
H0 minus H नहीं समझा सर. Means increase in the enthalpy.
HCl is at very low pressure, this is at high pressure, right? So difference क्या होता है? When you go from state 1 to state 2, what is the change in enthalpy? Delta G कैसे निकाला? G2 minus G1, right? ये है delta H, this delta H, H1 minus H2, या H2 minus H1, minus निकाल के H2 minus H1 कर सकते हैं. So change in enthalpy when you go from state 1 to state 2, from some pressure to zero pressure.
Yes, sir.
ठीक है?
Yes, sir.
Delta क्या रहता है? Delta is always change, ना? When I delta G means G2 minus G1. When I go from state 1 to state 2, what is change in gives free energy? Similarly, this is the change in enthalpy when I go from low pressure to high pressure or high pressure to low pressure. I can take minus out and say H minus H0 is delta H. ठीक है? So effect of pressure on
हाँ, sir.
figacity लिया हमने dg is equal to VdP RTDLNF ये इक्वेशन डेराइव किया था हमने. इट इज वेरी सिंपल. दबा ln f by दबा p at constant temperature is equal to V by RT. वेरी सिंपल. ये भी इक्वेशन सिमिलर है. पहला इक्वेशन जो डिराइव किया था हमने केमिकल पोटेंशियल वो भी ऐसे आया था. So equations are going to be similar because G or mu and F are related. ठीक है? This is very simple. So once you have defined fugacity, now we need to actually measure or determine. ठीक है? इसमें अभी डाउट है किसी को इसमें fugacity में? Yes, no. ठीक है. There is no response. I can't do anything. Okay. So determination of fugacity of
No,
pure
sir.
gases. Okay. So using compressibility factor, there are many methods of determining fugacity. Again, fugacity cannot be measured, so we have to find out or calculate. तो compressibility factor क्या है? Z डिफाइन किया ना आपने यूनिट CET1 में क्या होगा ना compressibility factor?
Yes, sir.
What is compressibility factor?
Measure of deviation from ideal gas.
Okay. So compressibility is nothing but volume of real gas upon volume of ideal gas at the same temperature and pressure. If I take a gas and if it is ideal gas, what is the volume? If it is real gas, what is the volume? Ratio of those two is the compressibility factor. That's how it is defined. And V ideal is nothing but RT by P, ideal gas law. So we can say V real upon V ideal, that is Z, is equal to P by RT, this is for ideal gas, into V real, volume of real gas. Or you can write V real upon RT is equal to Z upon P. Right? And we have seen daba ln F by daba P at constant T is equal to V by RT. We देखा, right? एक मिनट पहले देखा हमने ये डेरिवेशन. बराबर? So that is nothing but V by RT is Z by P. So that's the use of our derivation. Double function dependence of fugacity on pressure. So we can use that along with this equation. So what we get is dln f is equal to V by RT into dP or Z by P into dP. Right? So we can add dP by P minus dP by Pt because we want to get in some form. Right? Z into P by dP है ऑलरेडी. यहाँ पर प्लस dP by P किया माइनस dP by P किया, तो मिलेगा हमारे को dP by P इधर लिया और ये दोनों टर्म कंबाइन किया और डिवाइडेड Z minus 1 into dP by P. And dP by P is nothing but d ln P plus Z minus 1 dP by P. So if we take this on this side, d ln P, it will become d ln f by p, because it will become minus d ln f minus d ln p हो जाएगा, तो that is nothing but d ln f by p is equal to z minus 1 into dp by p. ठीक है, ये डेरिवेशन समझ में आया? सिंपल डेरिवेशन है, ज़्यादा कुछ नहीं कॉम्प्लिकेशन. So integrate this from 0 to pressure P. So what you get is ln f by P. This will be ln f by P, which is nothing but fugacity coefficient is equal to 0 to P z minus 1 by P dP. If you know the compressibility factor and pressure, you can integrate it from 0 to any pressure we want and find out f by P. And then once you know pressure, we can find out what is the fugacity of that gas at real gas at that pressure. We'll do some calculations. We'll see how it is calculated and how it varies from pressure. ठीक है, any questions? Question 1 पे. So ये अगर इंटीग्रल निकालना है तो we can do graphically. We can plot z minus 1 by p versus p and integrate from 0 to p. So we get this integral and that will give us fugacity. So example 6.22 है थर्मो बुक का. Let me see. Can I open it? Okay, so ये equation example है. Can you see this? Example 6.22.
Yes, sir.
Okay, so if you look at this one, it says derive an expression for the fugacity coefficient of a gas obeying the equation of state, which is P into V minus B equal to RT. So this is a modified form of Van der Waals equation. सिर्फ pressure effect ने निकाल दिया है, V minus B रखा है is equal to RT. And estimate the fugacity of ammonia at 10 bar and 298 Kelvin. Given that B is equal to 3.707 into 10 to the power minus 5 cubic meter per mole. So B का value दिया है यहाँ पर. So we have to substitute this in this equation and find out what is the fugacity value at 10 bar for ammonia. If ammonia is non-ideal gas, it cannot follow the ideal gas equation. So if we take this equation, P into V minus B equal to RT, what we get is PV is equal to RT plus P into V, and Z is equal to PV by RT. So that is nothing but divided this thing by RT. What you get is 1 plus PV by RT. Right? So if we take ln f by p is equal to ln phi integral, what was it? Z minus 1 by p into dp. So Z minus 1 ये लिया, तो what you get is p into b by RT, right? और dp by p था into Z minus 1 by p था. So Z minus 1 divided by p लिया, तो it is b by RT into dp. इसको इंटीग्रेट किया तो what you get is P into B by RT right? 0 to P, so it will become PB by RT, right? So fugacity coefficient is this ln F by P. For ammonia at 10 bar in 298 Kelvin, ln F divided by pressure is 10. You get substitute the value of B, 3.77 10 to the power minus 5. Pressure is 10 bar, 10 into 10 to the power of 5 kilopascal, divided by R, 8.314, temperature 298. So what we get is 0.015, and if you take what you call inverse ln inverse or exponential of this term, you get F is equal to 10.151 bar. So the value of fugacity for ammonia at 10 bar is not exactly 10 bar, but it is 10.151. So that is what is accounting for the non-idealities or interaction between the molecules. So this is essentially effective pressure for ammonia under those conditions. समझ में आया? सिंपल एप्लीकेशन है, ऐसे कुछ नहीं है, कॉम्प्लेक्स नहीं है कुछ.
हेलो, बेटा है सर, आवाज सुनाई दे रहा है आपको?
Okay. So let us proceed further.
हेलो, बेटा नहीं सर.
Yes, sir.
आई एम ऑडिबल नाउ. तो 2 मिनट में लेता हूँ आपके स्टूडेंट्स का.
क्या बोल रहे हैं आप?
कुछ मिनट लेता हूँ बोला मैं आपका.
Sure, sure. Yeah. Yes, please. Yes, sir. Please continue.
I think I hope I am audible to everybody. Yesterday there was a meeting with principal and so there was meeting with principal and I think admission related things were discussed. So many of you would have problems related admission, then paying up fees. So I would make things clear here, and if you have any question, you can ask me. So yesterday it was decided that everybody will have flexibility to pay fees. Means open category students, they will be paying in 3 installments. The first installment, it will be in this month only. You are permitted to pay up to 31st of July. Then second installment, it will be September 8th, and third installment, it will be November 8th. And other students taking concessions, scholarships. So those students will get only 2 installments. Half it. What total fees is there yearly? So half the payment you will make in first installment, and rest of the amount you will pay in November. All right. And then for this you need to make application. So I think many of you have already applied. I have seen the mails through your GFMS, and few people, if they have not applied, to take advantage of this, they can also apply. To apply through your GFM, seeking permission for paying fees in installments. All right. Then few students, they needed actually certificates like demand letter from college for loan purpose. They can also apply, even though many people they have applied already. So from Monday onwards, your queries they'll be solved by office. All right. So this yesterday was decided that I should tell. Means every HOD will tell to students. So that's why I'm here. So if you have some queries regarding admission and payment of fees, so you can ask from your side. I hope, I think my voice is able to reach you.
Yes, sir.
Okay. So anybody who wants to clarify few more things, if you have in mind?
Sir, amount for open category, the installment amount.
So it will be, I think, total fees divided by 3. So whatever it comes, maybe I think you can pay little less or little more. Little less means if your fees is around say 1,30,000, so maybe you can make it 45 and rest of the amount. It can also happen.
Okay, sir. Thank you, sir.
Yeah. Anybody else?
सर माझं ते आडनाव चुकलंय.
कोण बोलतोय?
भूषण डोळस सर.
हा बोला.
सर माझं ते ERP मध्ये सर आडनावच चुकलंय माझं.
ERP मध्ये का? ठीक आहे ना, तुम्ही तुमच्या GFM ला सांगा, ते करून देतील.
नाही सर, मी ताडकर सरांना पण सांगितलेलं हे आधी.
अच्छा, ठीक आहे. तुम्ही त्याचा स्नॅपशॉट मला पाठवा आणि आय विल गेट इट डन.
चालतं सर, थँक्यू.
ठीक.
आणि सर हॅलो.
हा या.
सर इन्स्टॉलमेंट पण भरू नाही शकलं तर काही ऑप्शन आहे का सर?
आता बघा, डिसिजन जे आहे, डिसिजन्स जे घेतात अथॉरिटी त्या वेगळ्या आहेत, आणि जर डिपार्टमेंट लेवलचं काही असलं तर आपण ते तेवढं ऍडजस्ट करतो, कदाचित मदत करू. पण हे डिसिजन्स त्यांनी कन्वे केलेले आहेत. मला वाटतं त्याच्यामध्ये आणखी काही चेंज होणार नाही. सध्या त्यांनी असं काही लिहिलेलं नाही त्यांनी की पेनाल्टी वगैरे, बट डेफिनेटली इफ समबडी ओव्हरस्टेप्स अ डेडलाईन, तर त्याच्यामध्ये होऊ शकते की म्हणजे काही फाईन किंवा पेनाल्टी असं प्रोव्हिजन असू शकते. तर ट्राय टू मेक, अदरवाइज यू गिव्ह ऍप्लिकेशन, मीन्स व्हाय यू नीड मोर टाइम.
सर मी ऑलरेडी सेंड केलं सर.
पण ते आता कदाचित परमिट करतील नाही करतील माहित नाही, पण तुम्हाला फ्लेक्झिबिलिटी ही दिली या पद्धतीमध्ये, जे मी बोललोय त्या पद्धतीमध्ये तुम्हाला फ्लेक्झिबिलिटी मिळालेली आहे. हा, आता मलाही सगळे सिच्युएशन माहित आहे की म्हणजे 4 महिन्यापासून आपण ज्या फेज मध्ये आहोत, तर प्रॉब्लेम सगळीकडे आहे, इन्क्लुडिंग वी ऑल्सो. पण आता त्याच्यामध्ये काय की सिस्टीम त्यालाही चालू ठेवायचं आहे आणि तुमच्यावर पण बर्डन नाही यायला पाहिजे, तर त्याच्यामुळे हे त्यांनी मिडल वे काढले.
सर
हा बोला.
सर आमच्या जिल्ह्यामध्ये सर 30 जुलैपर्यंत पूर्ण लॉकडाऊन आहे सर, बँक पण चालू नाही. मग 1 ऑगस्ट किंवा 3 ऑगस्ट पर्यंत भरले चालेल का?
कदाचित तुम्ही त्याच्यामध्ये जर मेन्शन करत असाल तर मेन्शन करून घ्या. पण दुसरे मोड्स आहेत ना तुमच्याकडे, तुम्ही कोणत्या मोडनं ट्रान्सफर करणार म्हणे?
सर UPI करणार होतो.
अच्छा, तर मग त्याला तुमची सिस्टीम घरीच असते ना, ती बँकेत जावं लागेल का त्याला?
हा सर, म्हणजे अकाउंट फक्त माझंच अकाउंट आहे, बाबांचं वगैरे काही नाही. मग माझ्या अकाउंटात एवढी मनी नाही आहे आणि बँक वगैरे सगळे बंद आहेत सर.
हा, जर ते बँक असतील तर जेन्युइन रिझन आहे त्याच्यामध्ये, मला वाटतं की तुमचं कन्सिडर करायला हवंच आणि करतील.
ओके सर.
पण एक सांगू इच्छितो मी की यू refrain from paying through credit cards and debit cards, कारण की it is inviting 18% of GST and it is a big amount if it is 1 lakh or so. तर कदाचित दुसरे जे कमी चार्जेस वाले पेमेंट मोड्स आहेत, so you use that, maybe ऑनलाईन बँकिंग, एकदम मिनिमल अमाऊंट मला वाटते चार्ज करतात. So every one of you discard payment through credit and debit cards.
ओके सर. सर मी हा प्रॉब्लेम सर नाणेवाडेकर सरांना पण सांगितलेला, ते मेंटॉर आहेत ना माझे.
अच्छा, ओके. हा,
तर म्हणजे
काही चिंता नाही. जर ते बँक्स बंद असतील, टोटल लॉकडाऊन असेल, तर यू कॅन नॉट हेल्प. तर त्याचं कदाचित आता तुम्ही मला इंटिमेट केलं तर इट विल बी इन माय माइंड ऑल्सो. सो इफ समथिंग हॅपन्स आय विल इंटरव्हीन.
ओके सर.
ठीक आहे. आणखी कोणाला काही विचारायचं आहे?
सर आम्ही कॉलेजमध्ये डीडी देऊ शकतो का? परमिशनच नाही जायला?
नाही, होऊ शकेल जर तुम्ही इफ यू कॅन कम डाऊन टू कॉलेज फ्रॉम मंडे कॉलेज इज ओपनिंग फॉर फॅकल्टी अँड स्टाफ maybe I think not on regular basis, but office will be open regularly throughout week, means Monday to Saturday. So in that case, you can come down by using proper precautions and give that. There is no problem. तुम्ही पुण्यामध्येच असता ना?
हो सर.
हा, मग तुम्ही येऊ शकता ऍक्च्युली, म्हणजे मास्क लावून त्याच्यानंतर जे काही आहे जे रूल्स ते फॉलो करत आले तर मला वाटते ते देऊ शकणार, डिपॉझिट करू शकणार कॉलेजमध्ये. ठीक आहे. चालेल. आणखी कोणाला काही बोलायचं आहे?
Hello, sir.
Yes.
Yes, sir. I wanted to know more about demand letter.
अच्छा, demand letter, if you are reading and you have already applied, so you can expect in early next week, maybe on Monday or Tuesday. तुम्हाला काय म्हणजे त्याच्यामध्ये आणखी काय डिमांड लेटर म्हणजे कॉलेज विल इन्क्लूड फीस, करेक्ट? कॉलेजची जी फीस आहे, जर तुम्हाला परत हॉस्टेलची वगैरे काही असेल, जर ती गोष्ट परत त्याच्यामध्ये इन्क्लूड करायचं असेल तर अल्टिमेटली यू कॅन हॅव टॉक विथ ऑफिस पर्सन. नाव त्याचं दिलेलं आहे ना, मला वाटतं सर्क्युलरमध्ये दिलेलं आहे.
म्हणजे ऑफिसला कॉन्टॅक्ट करावं लागेल ना?
नाही, तुम्ही ऑलरेडी मेल केलेला आहे, तर मेलमध्ये लिहिलेलं आहे का तुम्ही कोणकोणची अमाऊंट तुम्हाला इन्क्लूड करायची आहे त्याच्यामध्ये डिमांड लेटरमध्ये? डिमांड
लेटरचा मेल नाही, पण फीज बद्दल इन्स्टॉलमेंट बद्दल लिहिलेलं होतं फक्त. डिमांड लेटरचं नाही लिहिलं होतं.
एज्युकेशन कॉलेजकडूनच लेटर पाहिजे ना.
एक दुसरा मेल लिहावा लागेल का?
हा, मग त्याला पहिल्या मेलला तुम्ही फॉरगो करून त्याच्यामध्ये कम्प्लीट एकाच मेलमध्ये लिहा. म्हणजे जर तुम्ही एज्युकेशन लोन घेत असाल त्याच्यामध्ये यू डोंट नीड एनी फ्लेक्झिबिलिटी, दॅट एंटायर अमाऊंट इज सँक्शन बाय बँक इन वन गो. ठीक आहे. सो यू कॅन पे वन्स इट इज सँक्शन, सो यू कॅन रिक्वेस्ट फॉर that time until you get payment from bank.
Okay, sir.
Yeah, so accordingly you modify your letter and send it through DFM copy to me.
Okay, sir. Okay, sir.
बाकी आहे ना, सगळं क्लॅरिटी आहे सगळ्यांना? तर ठीक आहे. जर जर क्वेश्चन्स नसतील तर परत एक गोष्ट मी अकॅडमिक्स बद्दल आहे, सिन्स आय हॅव विजिटेड युअर क्लास, सो आय विल टेल दॅट this semester is going to be online mostly, maybe later somewhere in September or October, if conditions get relaxed, then you'll be visiting college physically. But as far as I see, and it is discussed so many times, that this semester is going to be online only, majoritarily. So you have seen means last semester, correct? And the assessment rules or assessment methodology. So even this semester, that same methodology will be adopted if things are like this only. So for that, you ensure your maximum attendance, because in assessment only three things will be counted for theory classes. One will be your attendance, second is your assignment performance, third is test performance. Okay, so it will be compiled. Then if it is for practicals, it will be practical assignments given online or something like that, and it's CAS regularly, attendance and CAS. So I will appeal here to all of you to maintain maximum attendance online. Secondly, you try to secure maximum marks in tests. There will be 6 tests, so probably your faculty would have told you. Then there will be minimum 3 assignments. Okay, if faculty desires to give more, so they can give, doesn't matter. Okay, so this performance in all this should be at higher side. You want to maximize your marks. Okay. So there is no project for you people, only I think theory and practicals. Even seminar probably is not there. So there is no much hassle. So methodology of calculation of your end sem marks will be like this. Okay. So as of now, probably we are not clear about the examination mode. But if it is same thing like last semester, 50% based on internal and 50% maybe if examination is devised or so. So you please be prepared for this, and ultimately department will not put anybody to loss. सगळ्यांना चांगल्या प्रकारे मार्क्स मिळायला पाहिजे हे डिपार्टमेंटचे धोरण राहील, प्रोव्हाइडेड तुम्ही ज्या गोष्टी सांगितलेल्या आहेत त्याला फॉलो करा. ओके. So this I wanted to tell you people. Already I have told to second year and final year students. Okay. Sir, if there are no questions, then I'll take your leave and Jethani sir will continue. So Jethani sir, there is I think no question from anybody, so you can continue. Still, I'll be here for a couple of minutes. Jethani sir. So, all right, I think he's waiting to see my exit, so I'm exiting. Yeah. Okay then.
Okay. Okay, so we have done this derivation ln f by p is equal to integral 0 to p z minus 1 by p dp, and we have seen the example also, right? So we have seen this. When you do the calculation, you'll see that fugacity is going to be different from pressure. Although pressure is 10 bar, the fugacity of ammonia at 10 bar is 10.151 bar. So that is what is showing the effect of non-idealities or real gases. Any doubts, questions on this? Any doubts, questions? No?
हेलो, एक
Yeah.
डाउट था कि जो वांडरवॉल्स इक्वेशन है ना, उसमें जो फैक्टर रहता है a by v स्क्वायर,
वो उसने बोला है कि this equation is to be used. उसने डेरिवेशन के लिए सिंपलीफाई कर दिया और कुछ नहीं.
नहीं मतलब जो फुगेसिटी है वो उस कांस्टेंट के इक्वल रहती है क्या a by v स्क्वायर को?
नहीं
f is equal to a by v स्क्वायर.
a by b square के अच्छा, you are saying that p plus a by b square लिया तो will it be
हाँ.
equal to fugacity?
हाँ हाँ.
Good question. Who is this?
सर देवेंद्र मोरे.
Devendra More. So okay, let's do an assignment. I don't know the answer to that question. What we can do is for ammonia, we can search for the value of a. मिल जाएगा. Or I'll see if I can find it, and then we'll calculate and see whether this and this matches. ठीक है? देवेंद्र.
Okay sir.
Okay. So what we'll do is I'll find out the value of a, and then we'll actually calculate p plus a by b square and see if it comes close to this fugacity value which you have calculated. So that will tell us. See, all these things ultimately what happens, you know, these are all approximations. Equations are always models, right? And what you must have heard is all models are wrong, but some are useful. So how close it is to reality, it depends on the model. So this may be 10.151, van der Waals equation may give 10.05 or 10.1. So it's not going to be exactly matching, but we'll check it. I'll check it and let you know on Monday. ठीक है? that is the homework assignment I will do, and you can also try. So next equation is using generalized charts. You must have seen charts of compressibility factor versus pressure, right? देखा था ना CET 1 में compressibility factor charts देखा कि नहीं देखा CET 1 में? हेलो,
यस सर।
अरे बोलो ना, यस सर, कुछ रिप्लाई नहीं देते क्या? So using those compressibility factor charts, we can actually do the calculation, right? So ln f by p is, ये हमने derive किया था 0 to p integral z minus 1 by p dp, right? So reduced pressure is nothing but actual pressure divided by pc. Pc is what? What is pc? p subscript c क्या होता है?
Critical pressure.
Critical pressure.
Right? So that means P is equal to PC into PR, and if you take the derivative, dP is equal to PC, because PC is a constant, into dPr. If you substitute in this equation, what you get is ln f by P is equal to integral 0 to PR. Instead of P, it will be PR. At P equal to at pressure P is PR. Z minus 1 by PC. P is nothing but PC into PR, and dP is PC into dPr. So PC cancels out, and what we get is ln f by P is equal to integral 0 to PR Z minus 1 by PR dPr. So you can get PR values from the compressive vector charts, and you can then plot phi, this phi versus PR, and these are type of curves which come. So different TR values, you can get phi value. And let me see if I can show you this figure 6.7. So this is the kind of chart we get. Fugacity coefficient versus reduced pressure. This is the one I showed. Fugacity coefficient versus reduced pressure at different value of T reduced. So if you know the pressure, you know critical pressure, PR, then if you know the temperature, you know TR, you can find out what is the fugacity coefficient. These charts are available. Okay, so this is simple, using graphically. Third method is using residual volumes. So we have dG is equal to VdP equal to RT dln f. Residual volume is what? Have you seen this in CET 1? Residual volume. Residual volume पढ़ा कि नहीं CET 1 में? No, याद नहीं है. So residual volume is volume of real gas minus volume of ideal gas. Suppose you take a real gas, you know the volume is say 1.01 cubic meters. If that gas would had behaved like an ideal gas, how much volume it would have occupied. So difference between real gas and ideal gas at the same temperature and pressure is residual volume, right? So residual volume is defined as alpha is equal to V minus V ideal is nothing but RT by P. You can take this on this side and you get V is equal to alpha plus RT by P, right? So we can substitute here V into dP, so alpha plus RT by P into dP is equal to RT dln f. So dln f becomes alpha divided by RT, alpha by RT plus 1 by P into dP. So what you get is dln f is equal to alpha by RT into dP plus dP by P, and this is nothing but dln P. If you bring it on left hand side, you get dln f minus dln P is equal to alpha by RT into dP, and we can write this as dln f by P. dln f minus dln P is dln f by P is equal to alpha by RT into dP, and if you integrate this from 0 to P, dln f by P is equal to 1 by RT is constant, integrate 0 to P alpha dP, and what you'll get is ln f by p is equal to 1 by RT integral 0 to p alpha into dv. So this is the derivation for residual volumes using residual volumes. Simple derivation. So what we do is we integrate this graphically. We plot alpha by RT versus pressure. We get some curve like this and integrate, find area under the curve from 0 to pressure P, and this area under the curve will be nothing but ln f by P. Okay? Any doubts, questions on this? Yes, no questions? Is good out there?
No, sir.
So you can, there are many methods of finding the, what do you call, fugacity. Next one is using equations of state. This will be a long one, so I will take it next time. This is going to take time. So we have seen three methods. This is the fourth one, and I think there is one more after this. Enthalpy values, and yeah, there are 5 methods. 5 or 6 methods. So we'll see those next time. Okay, so we'll not see this. So up to that equation using residual volumes. Okay. Any questions, doubts so far? So what we'll do is we'll have a test on Tuesday at 3 p.m. and mostly we'll use Google Forms. I'll share it with you at 3 p.m. and you can do it online. It will be mostly MCQs, but there will be some numericals also. You have to do some calculations and then give the answer, select the answer. And the portion will be what we have done so far till today. Any doubts, questions on test?
No.
ये नहीं रहेगा, ये let us see, ये I can remove this portion also, determination of fugacity. Determination of fugacity नहीं करने का, fugacity तक करने का, definition of fugacity तक करने का. Okay, will not include determination of fugacity, but fugacity concept will be there. ठीक है?
Okay, sir. Okay, sir.
Okay. So I'll stop the recording.